So thank you everyone for coming to the Pages Varves Working Group online seminar series. We have today Ola Kwiecien, if I said well. I try my best. So hello Ola. She's
Hello.
going to talk about seasonality. So Ola is a lecturer or senior lecturer at the University of North Cumbria in the UK. I met Ola during our PhD like many years ago in Potsdam at DFZ, and then we were meeting in conferences. So we are very good friends, and it's a pleasure to have you here. So thank you for giving a talk, and yeah, you can start whenever you want.
All right. Thank you, Silvia, very much for the invitation. And I have to say, I was pretty excited to give a talk for the VARV community because, well, I started as a paleolimnologist, but somehow I have never had the pleasure of working with VARVs properly. So I feel right now really very honored being able to talk about seasonality. And on the first slide, there's only my name, but I'm sorry, can I change this? Oh, right, good. I think I need to go around it. Yes, so the paper that Celia particularly asked me to talk about is a transdisciplinary teamwork. And it's with quite a huge number of co-authors. One of the co-authors on the paper is Saya Sarni, who gave the seminar for the same group 2 weeks ago. And so I'm just the front face on this paper, but indeed everything that we have done was a teamwork and a group work. And let me, no, okay, right now it works. So if one thinks on the seasonality on a human scale, the most of what we are experiences are diurnal and annual cycles. Diurnal cycles are actually pretty easy. So this is a day and night cycle, which comes about because of the Earth rotation around its own axis. The other thing is an annual cycle, which is a result of the Earth rotation around the sun. And with this, we have generally 4 seasons in the higher latitudes, 2 seasons in the lower latitudes. The way that I used to explain it to my students with a really very simple and conceptual example, and all VARV people know that this is just a conceptual one, because there are so many different mechanisms in which one can produce VARVs. So we have a lake. It's nice if the lake is poorly ventilated and has an anoxic bottom water, because this is something that actually makes, or without it, VARVs cannot be preserved. Without it, we would have a bioturbation. But apart from the anoxic bottom water, one of the things that is definitely crucial for production of deposition of VARVs is the annual or seasonal cycle of change in either material supply or the material production. So in this really simple case, we have winter and the tritone material will be coming into the lake. In summer, we might have pollen being transported into the lake, or carbonates precipitating in the surface water and then being deposited at the bottom. So you would have another layer, lighter layer in this case. Then through another winter, we would add some more detrital material. So you can already see, I don't know, yes, if you can see my mouse. So you already see the position of different layers at the bottom of the lake. And what we can also see sometimes within VARVs would be the exceptional events like event layers. And this might be related, for example, to the floods or like very intense and heavy precipitation events. And after several years of such a sequence, what we will end up is a nicely laminated sediment core. And this is, again, just a kind of concepts of how it might work. And this is right now the image that I borrowed from a paper from Saya's group, published only lately in 2023, which is the same picture that Saya has showed 2 weeks ago. It shows different types of laminations in Finnish lakes. these lakes are very close to each other. And in case of, well, the seasonality would be, if we would be thinking about seasonal changes on the same scale, sometimes it might be surprising that the expression of the seasonality is different in lakes which are so close to each other. The other, even more, I would say not necessarily drastic example, but very visual example is Lake Van. What you're looking at here right now are different sections of the core from the same coring site. They're all representing varve material. We are absolutely sure about A, that A are varves. When it comes to B, C, D, and E, they're slightly deeper, they're older. We don't have such a great age control, but most likely these are also varves. And we are looking at exactly the same lake, the same location, and the expression of the lamination, the way that the varves are looking is different. Further, or yeah, even more interesting is that if we are looking at the other sequences, other sections in the core, the lamination changes from something towards lamination that not necessarily needs to be varve. And there are way more of these flood layers, or the layers that are also related to intense precipitation events. And the natural question will be, so what changes in the Lake Van surrounding, or what changes within the environmental conditions to produce such a different sediment type? And one of the one of the answer that kind of presents itself would be changing seasonality. Obviously, the seasonality has changed, so the expression of this in the varve record, in the sedimentary record, is different. And yeah, this is exactly, so far so good if you're giving just a simple answer. But now the question would be, so what has actually changed? How does it work with seasonality? And in terms of climate seasonality, we are talking about two components. One is temperature, one is precipitation. It's also better to talk about annual cycles than the seasonal cycles. We may talk about seasonal variability, but actually the cycle takes the whole year. So that's why this would be an annual cycle of the temperature. Temperature is relatively easy because it's symmetrically distributed along the year or during the year, and the temperature is best characterized by the maxima and the minima, so basically by the amplitude. Why this is important? Because if you look at the picture here, so you see the orange line, which has way lower amplitude than the red line, but if you will try to take their means, the means will be exactly the same, although the amplitude and the maxima and minima are different. So this is something really important to remember about the annual cycle of the temperature. If we are looking at the precipitation, there's additional factor to it. So we can talk about the magnitude of precipitation, so how much it rains, but what is also important is distribution, and within distribution, I mean timing and duration. So when the rainy season starts and how long it lasts. And again, this is just one example, totally theoretical example of how the precipitation can look like throughout the year. But right now, if you will look at another example, the amount of the rain falling is exactly the same, but the distribution is very much different. And this would be the third example, where again, the amount of the rain is the same as in the previous sketches, but the distribution is completely different. So it just brings about the idea, or the very important concept, that climate is defined not by means, but by annual cycle of variables composing it. And one thing is exactly, so what do we understand talking about seasonality and seasonal change? The other thing really very important is looking at the archive. So what actually the archive that we are working with can record. And now here again, you have we have four theoretical curves of annual temperature cycle. The temperature like ranging between minus 10 and 30. in case if you see a small snail in the right bottom corner of the screen and you wonder what the snail is doing there, I came up with this idea of this representation of the sketch working with land snails, and somehow the land snail became a permanent addition to this slide. But coming to the data, so yeah, we have the different ranges, different variability of the temperature, and what might happen is that we can be working with the archive that has only a certain period of activity. So I guess right now it actually explains the snail, because snails are active or actively growing only during the certain range of temperatures, generally between 20 and 27 degrees. But the same case might be for any archive that we'll be working with. And I imagine in case of lakes, this is something that Saya explained 2 weeks ago. And not only Finnish lakes, but quite a lot of high latitude lakes, they freeze in winter, which means that winter might be the period that is not necessarily recorded, or the processes that are happening in the winter are recorded, but not during the season during which they are actually happening. So this is something pretty important to consider, talking about seasonality. Also, the sampling resolution is pretty important, because we might be able to sample the whole range of the parameter that we are interested in. But again, it might be that we will be sampling only the part of the parameter that the archive allows us to see, that the archive records. And in this case, it's also pretty important to think about the high resolution sampling or bulk sampling of the parameter, or analysis of the parameter, because again, it might bring some bias into the interpretation, into our further interpretation. One other thing that I want to point out on this figure is that sometimes what can happen is that not necessarily the amplitude, the annual amplitude of temperature might change, temperature or precipitation, but we will see something like a shift in the baseline. And again, depending on how we are sampling and what is the activity period of our archive, we might easily misinterpret it. So right now, just again, to make it pretty visible, in terms of the dark blue temperature curve has exactly the same amplitude as the light blue temperature curve. But in case if there would be a shift in the baseline, we might actually, if we, independent whether we will be doing high resolution sampling or bulk sampling, it might look like that the seasonality has decreased, that the seasonality is dampened, which is not necessarily the case. We are just simply capturing, or our archive is capturing a shorter period, and this is what is happening. Right. So right now we have covered what is the seasonality of, or what is the annual cycle of temperature, what's important, what's the seasonal cycle of precipitation, what's important there, and different caveats related to the archive that we are working. But seasonality does change, and we know that it changes. Few fundamentals about it is external forcing. So this is the amplitude of seasonal insolation changes. This is obviously external, as related to solar, not activity, yeah, but it's related to solar energy. And generally, the variability in the insolation is lower at the lower latitudes. So this is again here expressed with the few curves here. I'm not talking about the amount of the insolation, just about the variability of the insolation, right? Right. So it's definitely lower at the lower latitudes, and then it's definitely higher. The variability or the amplitude is higher at the higher latitudes, which is again here color coded. Another very important factor is atmospheric CO2 concentration. This is a global factor, and I think that at least for the some of the geological timescales that we are working with, we can take it maybe not necessarily for granted, but we can take it for constant. It's not necessarily the case with the most recent events, but I will come to that later. However, these two factors are really very important, and later what comes to it will be the internal factors. But first I would like to focus on the external forcing. And external forcing is related, or changes in it are related to orbital parameters, which is obliquity, eccentricity, and precession. And I'm pretty sure that everybody has at least once seen or used one of these famous insolation curves, mostly used for Jones 65 degrees north, which is it's the latitude to which the northern hemisphere ice sheets are responding with waning or waxing. Now, the thing is that, yeah, as I said, quite a lot of scientists are using these curves, but it's not quite intuitive, I would say, what is actually coming into it, or how this insolation for June in a certain latitude should be understood or should be interpreted. So now let us make a very easy thought experiment. Imagine that we have a planet like Earth, which has a circular orbit. So the orbit is round and there's no tilt, and it's orbiting around the sun. In this case, we would have no seasonal variability because each latitude would be getting exactly the same amount of insolation throughout the year. But what we would have would be the latitudinal gradients. So the equator would be still much warmer than the poles. And the length of the day would be exactly the same throughout the globe. Now, from this, we can go a step further and we can add a tilt. So the orbit is still circular, but right now we have the tilt. Let's give it a modern tilt of 23.4 degrees. So right now with this, we are actually introducing the seasons. The hemisphere that would be tilted towards the sun, orbiting around the sun, would experience summer, and the hemisphere that would be tilted back or away from the sun during its rotation on the orbit would be experiencing winter. However, and with this, so we are introducing right now not only seasons, but a different length of day during the year. And this is something that I very painfully feel right now in Northeast England, that the summer days are definitely shorter. However, in this case, yes, so we would already have seasons, but the seasons would be still distributed, or they will be still very symmetrical on both hemispheres. What we can do to approach the real situation of Earth is add the eccentricity of the orbit and then later on the precession. With the eccentricity of the orbit, the length of seasons would be different because the distance between the sun and the Earth throughout the year would be changing. So sun wouldn't be in a center of this ecliptical orbit, but in one of the foci, meaning that once Earth would be closer to the sun and once would be further away. With this also, it's one thing is that the distance is changing, but also the speed with which the Earth rotates around the sun, because of the gravity. When it's closer to sun, it rotates faster, or it moves faster. When it's further away from the sun, it's slower. So with this, to the seasons that we already have, they would also differ for different hemispheres. And right now we are actually introducing the seasonal gradients. So season as aphelion, further away from the sun, are colder and longer, which means that in this situation that you see right now, and this is a modern situation, northern hemisphere summer is cooler and longer than southern hemisphere summer. So at the moment, it means that the gradient between summer and winter insolation is steeper in the southern hemisphere than the northern hemisphere. Right, now if we will add precession to it, so the precession is the rotation of the Earth axis actually, it means that the situation wouldn't be again stationary, it would change every, give or take 20, 21, 23,000 years. So this is actually the mechanism at which we can change the gradients in between summer and winter for different hemispheres, and at the same time for the certain location on the continents. So now from this we can, oh yes, I forgot to mention that this is something really very important, because these are these small changes in annual insolation that accumulate into large scale changes, for example, glacial interglacial cycles. So this is actually how these changes come about, by the small changes in seasonality. Now, if we will come back to the modern situation, so with the northern hemisphere tilted towards sun during the northern hemisphere summer, meaning that our summer is slightly cooler and winter is slightly warmer than equivalent on the southern hemisphere. So it means that the gradient between summer and winter is less steep on the northern hemisphere. However, insolation is not the only thing that matters actually. What also matters for the gradient between the hemispheres is the continent and ocean distribution. And as it happens right now, the northern hemisphere has much more continent and much less ocean in comparison to the southern hemisphere. So this is a factor that is slightly, maybe not offsetting, but slightly counteracting the seasonality gradients which are prescribed by the external forcing and the solar insolation. So yeah, it's not all that matters for how the seasonality is felt. So right now we can come to this second fundamental of seasonal variability, which is external forcing and the CO2 concentration. And the interesting thing is, again, that over the time scales that we are normally working, I would say the CO2 concentration is relatively stable. However, what is happening lately, and this was published in 2018, is that human activities are indeed changing seasonal cycles worldwide. What is happening is, where there are two different processes. One is that the general temperature gradient between the tropics and the high latitudes is decreasing. But that's only one part of the story. What is also happening with this decreasing gradient is that the atmospheric circulation patterns are changing, and they are leading to increased temperature gradient and throughout the year. And this gradient is increasing, or the increase of this gradient is much higher at the higher latitudes and is lower at the lower latitudes. So this is something that we are indeed tampering with adding much more CO2 concentration or CO2 into the atmosphere. We definitely do change or do alter seasonal climate cycles worldwide. Right, and the fact is that with the global warming predictions, well, it's difficult to say how it will look like, but it's important to note that the recent seasonality that we can observe, that we are living through, is not necessarily, or its changes, these are not necessarily good equivalents for this what we have seen in the past, mostly because right now we are definitely shifting the baseline with increasing atmospheric CO2 concentration. And last but not least, thinking about the fundamentals of seasonal variability, the huge thing are internal feedbacks. So in internal feedbacks, I mean like land cover or the medium, continentality, altitude, and atmospheric circulation. So the thing is that if you look right now, if you look back into this external forcing, so you have prescribed insolation intensity that is hitting a certain point, certain altitude, certain latitude, at the surface of the Earth. But these points, if you would call it a grade on a globus, it's not necessarily homogeneous. So we will have indeed a very different constellation between the land and the sea, between the land cover and between the altitude too. And this is something that is really important, I think. So it brings, what it does is that the temperature variation experienced at the site might be different than the one that is prescribed by the calculated external forcing. And to top it, what the archive is recording might be still just a part of the story. So I think that this is something really, again, really important to consider when we are talking about past seasonal changes. Now, just to make it even slightly more visual or tangible, that the locations which might have even a very similar latitude do experience different seasonal amplitude of seasonal cycles, both in temperature and precipitation. So this is generally what this map is showing. If you would like to look at the Northern Australia and Andes, which are both at the rather similar latitude in the Southern Hemisphere, so this is the Andes are the red point here, obviously, and Northern Australia is the orange point in the Northern Australia. And the range of the annual precipitation and temperatures for these two is very much different. Similar thing will be happening if you're looking at the British Columbia, which is here in the Northern Hemisphere, and someplace in Northern Europe, which actually right now looks like Germany. And again, if you will look at the modern recorded range of precipitation in a seasonal cycle, annual cycle, and the temperature in an annual cycle, these two locations have very, very different, the values for these locations are very different. And this is indeed related to factors like continentality, altitude, and large-scale circulation patterns. All right, so that's a generally like big picture that you can see on I would say global scales. These are just few points that we have chosen. On a smaller scale, this is an example from the paper from Annabelle Wolf, who actually is also co-author of the seasonality paper. And right now you're looking at much smaller spatial scale. This is generally Indochina. But already here, Indochina and this region is very important for monsoon. So, and obviously when we are thinking about monsoon, we are thinking about the precipitation and rainfall. And this figure simply shows how different the annual precipitation distribution is in several locations, which are actually very close to each other. So again, this is related to the spatial heterogeneity, and it's not something that we can take for granted that if the latitude of a certain position is very similar, then the seasonality of either rainfall or temperature in this place will be exactly the same. Right, so to sum up, I think that I have pretty rushed out through my presentation, but to sum up, I would say that when we are talking about seasonality or paleoseasonality, we should definitely keep in mind that climate archives may not cover the full scope or actual seasonal changes, and that the archives are much better at capturing the amplitude of the change than the distribution. Obviously, talking about the temperature distribution is not much of a problem, but if you're thinking about the precipitation, then the distribution, it's very difficult to reconstruct past precipitation distribution. The other maybe kind of take-home points are that the regional and local expression of seasonal changes is a consequence of semi-stochastic or stochastic and internal feedbacks, which are superimposed on predictable external solar forcing. By predictable, I mean, yes, we can to a certain degree predict it, but it's also prescribed by the physical formulas. We can simply calculate it. But still, this what we can calculate does not necessarily be directly translated to the changes that we see in the archive. Most important factors modulating the seasonal signals are continentality and altitude. And these two are relatively constant over long time scales. So for most of the works that we do, they stay constant. However, the large scale atmospheric circulation patterns, these change, and they also have a potential of changing the seasonality signals. Now, I would say that the archive sensitivity and proxy understanding matters. And again, I would very briefly link or relate here to the presentation given 2 weeks ago by Saya, when she was saying exactly comparing different lakes from Finland and saying that it's very important to understand the local environment of the lake and also how the large atmospheric circulation patterns affect the certain region, because other way around, it might be that our interpretation of the changes that we see in the Varves system and the Varves record is not correct. And last but not least, I would like to say that the global warming is shifting the baseline for internal feedbacks. So again, what we see right now, we see changes in seasonal cycle, definitely, but these changes are related to something else than the changes that we might have seen or that we've seen in the past records. And I think to finish the talk on funny note, I would say, how will seasonality change under global warming scenario? Postillon is one of my favorite German online magazines. It's a satiric online magazine. And a few years back, I think it was actually, so this was January 2018, they published an article that because of the climate change and because the seasons are changing and winter is right now, winter right now is a kind of luxury in most of the places. Winter like I remember from my childhood with snow. So that's the reason why Italian restaurants will be able only to serve pizza 3 seasons. The pizza 4 seasons will be no longer available in the restaurants, and with a little bit of the outlook that soon only Pizza Hawaii will stay on the menu. So, and yeah, I actually coming back to the snow, I do hope that I will see some snow this winter, because I can't remember the last time that I have seen it. And yeah, thank you very much for your attention, and I think that I will be ready to take questions.